Let's review a little bit of oxirane or epoxide nomenclature. So let's try to name these four compounds as oxirane. So if we start with compound 1, whenever we have an oxirane, and the oxirane is the three-membered ring containing oxygen in it, whenever we have two groups that are identical on each side of the oxirane ring at position 2 and position 3, so let me label that. When we're dealing with an oxirane, we always label the oxygen as number 1, and then 2 and 3. It doesn't matter which side I choose for 2 or 3 since both sides have propyl groups on them. So when we have this kind of arrangement on an oxirane, we can call this cis 2,3 dipropyl oxirane. So cis 2,3 dipropyl oxirane. And if the stereocenter of one of those propyl groups was inverted, then it would be trans 2,3 dipropyl oxirane. So let's take a look at example number 2. So again, we start naming our oxirane, or start numbering it, excuse me. Always start with the oxygen as number 1. But we're going to put the carbon on the left as carbon 2 because it's the only one that has any kind of carbon substituents. And carbon 3 only has hydrogens on it, so it's going to take a lower priority. So we have our oxirane, and we have 2 propyl groups on carbon 2. So this is going to be, let me change here, it's going to be 2,2-dipropyl oxirane. 2,2-dipropyl oxirane. We don't need to indicate cis or trans because there's nothing on the other side of the ring. There's no stereochemistry because the two R groups are both identical, so there's no stereochemistry to report there. So 2,2-dipropyl oxirane. Let's look at number 3. And number 3, we're missing, or we haven't shown the hydrogen going back here. So our stereochemistry, again, you should know how to name the number the oxirane by now. But if we just look at the stereochemistry at this stereocenter here, you can see that this is going to be first priority, and what's going to take second priority will be this phenyl ring. So it'll be 1, 2, 3. So that means our stereochemistry is going this way. So this is going to be S stereochemistry. So it's going to be S, our compound will be S, and our oxirane is going to be numbered. I'll number it in red just to reiterate. It's going to be carbon 1, 2, and 3. Again, number 2 has a substituent on it. Number 3 doesn't have a substituent on it, so it takes lowest priority. So it's going to be S, and then we have a substituent at carbon 2, 2-phenyl oxirane. S2-phenyl oxirane. Let's take a look at this last example here. So I don't know what I did there. Okay. So let's take a look at this last example. So we look for the longest carbon chain in the molecule. You can see there's a chain that goes 1, 2, 3, 4, 5, 6, 7, 8. But we're not naming it that way. We're naming it according to the oxirane system. So we're going to put number 1 is still going to be the oxygen of our oxirane ring, and carbon 2 will be the carbon with the larger group on it, and carbon 3 will be the one with the smaller group on it. So what's going to be our 2 group? So let's see, what are our 2 groups? What are our 2 groups that we have? So on this side we have a sec-butyl group, and on this side we have an ethyl group. So as you probably know, B comes before E in the alphabet, so we're going to report that first. So it's going to be 2-sec-butyl, 3 2-sec-butyl, 3-ethyl oxirane. 2-sec-butyl, 3-ethyl oxirane. So that gives you an idea how to name some epoxides or oxiranes. This is using the oxirane naming system. So hopefully this will help you. And these are the kinds of questions that you will see on the quiz next Monday.